a lot of the information about Prediction Builder you can get from the internet. If you just Google Salesforce Einstein Prediction Builder, there's a lot of trailheads that'll walk you through it. And the advantage that you'll have today is that we can make this more of a dialogue. So as I walk through this demo, feel free to ask questions, and I may table some because they'll be answered later in the demo, but overall, I think if we have a dialogue, we can do a lot towards accelerating your understanding of the product and how to use it. So we're going to cover this. We're going to cover this agenda. First, we're going to talk about your data. And a big part of having success with Prediction Builder is preparing your data and then getting it into Salesforce and then building your prediction from there. So as far as data goes, what interests you? What data do you have access to? What data do you want to build predictions on? So one of my favorites is actually, I use healthdata.gov. They have a lot of information resources available and data sets that you can browse. So if you go to their recent data sets view here, you can see that there's a lot of information that you can get, public information, health data, COVID data. One of my favorites, though, is this Social Determinants and Health Equity Resource Guide. If we look at that, we view the data, then we can actually look at different data sets from the Centers for Disease Control, Medicare, Medicaid, and even the US Census Bureau. So the one that interested me for this demo was one that's called US Census County Business Patterns. And so if we look at that data, basically what it's going to tell us is the number of establishments, employment numbers, payroll information, by congressional district. And the important thing about why I selected this data is you can see that we have a time series data. So when we're talking about predictions, the questions you're going to want to ask about the data that you want to use is, obviously with a prediction, it implies one of two things: either that there's a time series because you're predicting, based on past data, I want to predict future data. So this fits that aspect in terms of building a good prediction, is that we have time series data. The other way that you can do a prediction is, so what category, how do I categorize data based on the way that I've categorized things in the past? What is this new part of new data? How is it going to get categorized? And so we're going to look at both of those aspects. So when I pulled this data down, this is what it looks like here. So we have data about, so it's state, there's data for each state. And then basically we have the number of establishments, the number of employment, payroll data by these different industry types, okay? So, and then some other columns that indicate maybe the noise in the data. So I thought this was kind of interesting, and I wanted to build a prediction around it. So I downloaded each spreadsheet for each year and put them together into one spreadsheet that basically had all the data for across all the years. So you can see you've got 2020, and eventually if I scroll down far enough, I've got 2019, 2018, so and so. So that gives us a good time series data. That means maybe we can try to predict what this data might look like for 2022 or 2021. So those are kind of the other thing that I thought this would be interesting data for using with Prediction Builder is we have different states. And so maybe in terms of categorization, we could categorize red states versus blue states, and then use that data to determine whether a swing state was going to be red or blue, that kind of stuff, right? So we're having fun. Those are the kind of things that we can do. So the key point here is that you're going to want to think about what kind of data interests you, and access that data and then get it into some kind of column format, and basically a CSV file is sufficient. So if you can get it into Excel, then you can export it to CSV, and then that's all you basically need to then get it into Salesforce, and we'll look at that in a moment. So that's, in terms of getting your data, there's some suggestions there. The next thing you're going to need to do is you're going to need to create a Salesforce org. All right, and this link will get you to this page where you just fill out some information about yourself, your email address, that kind of thing. And then it will create an org for you and send you an email with your login information. And then you will, for free, you will get your own Salesforce org. This QR code will also get you to this URL as well. So that'll be an important step in the process of getting yourself set up to using Prediction Builder. We're moving fast here, but does anybody have any questions so far? Okay. All right. So then once you have your org, and I've already did that process that I just talked about. And so here I am. I have my Salesforce org. And again, there are trailheads and a lot of video information available. As you can see here, I did a Salesforce query or a query in Google, and I can get videos on how to create an org, how to create custom objects, that kind of thing. But once you have your org set up and you're logged in, this is what you'll see. And if you don't see yourself in the setup, one of the key things is you see there's this gear icon up in the upper right, and that will always allow you to basically access the setup page. Okay. So that's how you generally, and what I mean by setup is this is the portion of Salesforce where you act as an administrator, like you configure your org, as opposed to being an end user where you might, use the functions of those. So that's the general idea of setup. And you can see that from here, if we just type in Einstein, then we can see that, yeah, actually, look, here's Einstein Prediction Builder. So I can access it here, or you'll notice that there's a tile already available where I can click into it here as well. That's an important concept to keep in mind in terms of navigating Salesforce, is that you have this search bar, which will allow you to get to a lot of functions. Like when you want to import your data, I type in import here, and there it is, the data import wizard. So, but we're jumping ahead. So I can click on get started here, and it's going to take me to my Einstein Prediction Builder where I can start adding predictions. But we don't have our data in there yet, right? And that's the key piece, is we created that spreadsheet. And so now what we want to do is, in order to import that data, we have to define what's called a custom object. And since my data is based on this county business patterns data, right? What I did was I created a county business pattern custom object. I did that by going to create new custom object. And then essentially all I do then is I name that object, and we'll just call it C county business pattern, and we're going to have fun, so I'll add that in there. And then basically I just save. Oh, it wants a plural form of my object. That's so I'll do that, and we'll save. And then what I can do is now I can go to fields and relationships, and I can start adding fields to that object. And so the key point here is that if you have an Excel spreadsheet of data, and what you want to do is map the columns in your Excel spreadsheet, those become fields on your custom object, right? So that's essentially how you're going to map whatever data you have that you're interested in developing predictions on into a Salesforce custom object that we can then perform those predictions on. So you can see that all the columns in my spreadsheet become fields that I've added to that custom object. All right, so I've already done that work to save us time. And so you can see that that's what I did here, is I created this object called county business patterns. And so now I have all these fields that basically correspond to the columns in the spreadsheet that we looked at. Any questions so far? Okay. The only other thing I want to point out is that when I define a field, I just start off by saying what's the data type of that field. So you can create fields that are a number, a date, a time, a currency, text, all that kind of, even URLs, Boolean fields like a checkbox field, that kind of stuff. So keep that in mind as you're thinking about the data that you want to bring into the system, and what fields you want to build your predictions on. So at this point, we've mapped the columns in our spreadsheet to fields on a custom object in Salesforce, right? And that's a big step already, but the data is in the spreadsheet. And I want to get each row in this spreadsheet to be a record, one record in of that custom object in Salesforce. So basically, then we go up here and we type in import, and that brings us to the data import wizard. And essentially, I'm not going to walk, but you get this screen, and then you launch a wizard that will then allow you to find the object that we created. And in my case, it was county business patterns. And then we'll tell it that we want to add new records or update existing records. But generally, you're gonna add new records, and you're gonna match by the name of the column, right? And then we'll leave it at that. And then you can see here, then I would drag my spreadsheet right on top of that, and that's how it's going to know that I want to bring that, where we're going to source the data from. So I would just drag it in there like that. But I've essentially done all that already to save us time, because that will take some time. And so we'll kind of breeze through that aspect of it. But essentially, yeah, we created our custom object. We're mapping columns to fields. We use the data import. And then there's a step where we map each field that we've defined in Salesforce to the columns that are in that spreadsheet. And then essentially at that point, we begin the import process. And so what I end up with is all of that data in Salesforce. And so I've got an app here I've called Data Scientist, and you can see that I've got a tab, and we can look at all of the data that I imported. So there you go. All those rows that we saw in that spreadsheet are now in Salesforce, and we're ready to basically build our predictions. So we're about to have some fun. All right, so that's the data prep side of all this. That's where you get to have some fun. You get to make some choices about what data you want to bring in, and in order to build your predictions. Exactly. Thank you. Okay, so we're going to go and start that experience. So we'll go back to setup, and we're going to go to Prediction Builder, and now the fun can begin. So what we're going to do is we're going to build a new prediction. And so the first thing that we're going to do is give this prediction a name. So so we've kind of made the decision then that, what we're interested in is we have this time series data. We want to predict what the 2022 data will look like. But you want to think like a data scientist. And before you build a prediction, you kind of want to validate your prediction. So we know we have data from like 2017 to 2020. So why don't we set it up by predicting the 2020 data? And then we'll see. We'll be able to compare the predicted value against the actual data and build our confidence in the model. And to the degree that they're not matching up, we'll tweak the model. And then once we've got the model where we feel it's working, then we'll create a prediction to build 2022. So this is the way the data scientists think. Okay, so we're going to do that. So we're going to start by building 2020 data, and we're going to predict the annual payroll data. That was one of the columns that we have here is annual payroll for each industry. So you can see that. So that's what we want to predict, is the annual payroll for each industry for each state. Okay. So and I'm gonna add a 2 to it because I've actually already built a prediction for this, and so I have to create a unique name. And we're gonna create a numeric prediction. Now, so this is where I was talking about in terms of we have a choice about what we want to predict. If we're predicting time series data, then very much it's going to be a numeric prediction because we want to predict the annual payroll for 2020. But if we were going to do kind of a red state versus blue state comparison type thing, we're going to look at that later. We would do a yes, no, or binary classification type of prediction. So first, we're going to start with a numeric prediction. And so we're going to save that. And now we're going to select the data that we want to predict on. And so you can see that there's a lot of standard Salesforce objects in here. There's that one that we created, is already listed, and then the one I created and we already imported all the data into. And that's the key point, because you can't build a prediction without data. We don't really have any data for the rest of these, so we're going to select this one because we know that we have data for that custom object that we imported, right? And it's telling us, you can see here, it's telling us that, up here, you'll notice there's this thing called the data checker. So as we're going through this step-by-step wizard of naming our prediction, defining the type, selecting the object, one thing that we get up here is if we expand this, it's telling us a little bit about the data that we're building this prediction on. And so it's saying, okay, yeah, we see that you have about 1,400 records of this county business pattern data that you've imported. And that's good. It's giving us a green light because it needs at least 400 total to build a good prediction. So this is something you're going to kind of want to track. You know, sometimes you might look up here and it might have like a red a circle with a red line through it. I mean, that's basically telling you you don't have enough data to build your prediction, and you would have to import more. So that's another, aspect of being successful here, is getting there's the data you're interested in, but having enough of it so that you can successfully build your prediction. Okay, and then so what we're being asked here is, how much of that data, how much of that 1,400 do you want to create your prediction on? So what we could do is we could segment it. We could say, well, you know what? My first prediction, I only want to build on the Alaska data set, or maybe, states north of some longitude, whatever. And then, so then what you would do then is, if I selected that, then I get this piece here where then I can say, okay, well then, I have to select the states where, and then, provide, the value, so that we're segmenting the data, because we only really want to build a prediction specific to that segment of our data. And if it was multiple, then we would say, okay, all states or all conditions, and then I would keep going. And so I would add another state and say equals, I don't know, Arizona, and so on and so forth. So then, now we're building a prediction just on the portion of our data that corresponds to Alaska and Arizona. Okay, so that's an option that you have in terms of defining your prediction. But actually, in our case, I'm not interested in segmenting the data at all this first go around. What we're going to do is we're just going to use all our data. Okay, but that is a consideration that you have, and a choice that you have in terms of, you could define one prediction on Alaska data and a different prediction on Arizona data, for instance, if you wanted to segment it that way. But in this case, for the sake of being succinct, we're just going to go ahead and select all of our data and hit next. Okay, we're moving fast, but this is your opportunity to ask questions. Any questions, comments?
Actually, I have a question. Who's your target audience? Like the end user of the Einstein Prediction Builder? Did you intend it for data scientists, data analysts, or folks in design?
Yeah, no, great question. I'm glad you asked that. So part of that was given away by the fact that in order to get to this prediction builder capability, we had to go into the setup portion of Salesforce, right? So that you can't access this capability as a regular user of Salesforce. So already we're implying that you have to at least be a Salesforce administrator. So you're not like an engineer per se, but you're somebody who has administrative knowledge on Salesforce. You're not a data scientist. Most of the people that fit that profile are not data scientists. And so that's a very relevant question. And so what you can see is we're moving along here is quite a bit of the real estate that we're providing in this application from step one even there's a lot of real estate that we're dedicating to explaining what they're doing, because these are, in fact, people who are not data scientists. And so as we go along, we're trying to explain these concepts, and you'll see in a lot of cases, we have a tell me more link on the page that takes them to Salesforce help content that drills down into what a lot of the, what the data checker means and a lot of what these choices mean. So does that answer your question?
So Juliet, just to reiterate that, so it is geared towards the low and medium AI maturity customers. That means that people who are data aware admins. So you can be an admin, as JP mentioned. Setup is something which is used by Salesforce admins and they have access to it. But because it is something that you're building predictions, you're building AI models, so you need to be aware of how the data is used in your org. So there is this subset of personas that have recently emerged called data aware admins. And some people they call them citizen data scientists. So they are not people who are like pro machine learning or AI users, but these are people who understand data.
Interesting. Sorry, I've been living in the trenches a little too long, so thank you.
Sure.
Great. No, that was a good question. Thank you. Any other questions? All right, good. Okay, so then to reiterate, we gave our prediction a name. We determined that it's going to be a numeric prediction. We selected our custom object that we imported data for. We decided that we're not going to segment that data. And then now it wants us to define our example set. And what we mean by example set here is the set of data that we're going to train our AI models on. So this would be a subset of all the data. We brought in 1,400 records, but what we're saying now is, give us some portion of that data that we're going to train the model on, and then another set of that part of the data that we will predict. And then that's how, and as I said earlier, so what I kind of decided is we're going to use 2017 through 2019 as our training data. And then we're going to leave the 2020 data out of it and generate predictions for that data so that we can compare the predicted value versus the actual value. And then using that contrast, it could tweak our model so that we get it to where we're comfortable to say, okay, it's in a good place. Now let's predict 2022 data. So that's this idea of this example data set but the first question I have to answer is, what am I trying to predict? Of all the fields that were in that spreadsheet, there was the employment data, the establishment data. The one I said I was interested in was annual payroll. So that's what we're specifying here. And then we're going to do what I just said, which is we're going to, we want to look at the report date is earlier than or equal to 20, actually I have to give it a date. So we're going to go back to 2019, and actually we're going to go to 2020 and then get the last day of 2019. Oh, no, I did something wrong there. Okay, so we're going to, okay, so we got to go to the beginning of the year. Okay, so we're going to get the last day of 2019. All right, so what we've just said is we're going to train our data on all the data before 2020. And of course, what it's implying here by these fields that I can't edit is that we also only want to include data where we have annual payroll data. Like if that value is null or 0 or what, then we definitely don't want to include that in our training data. So that's what this piece of the information is telling here. So we've decided that we're going to predict annual payroll data. We're going to train our models based on all data before 2020. Any questions about that before we continue? All right, and remember I say you keep an eye on data checker up here. Right now it's in pause mode because it's not sure whether we have enough data, and it won't be sure until we say save. And then so now the data checker is going to look at our data, and it's going to, okay, indeed it found that we have about 1,000 records of data before 2020. And so if we look in detail, it's telling us that at a minimum, we needed 400 rows of data. We have 1,000, so we're good. And then this records to predict, it's already figured out that the 2020 data itself is about 340 records. So it looks like we're all set up to create a successful prediction. So I'll go ahead and say next. And now we're going to tell it, okay, of all that columns in that spreadsheet that we brought in, which ones do we want to use to inform our model? And so, one of the things is all this data was created by me. So I don't think that's particularly useful for the data model. The name of each row is just a combination of the date and the state. So I don't think that's going to be particularly useful. Yeah, I think the congressional district data would be useful for the model. I think the annual payroll noise might be. I have no idea. The employment data should be useful for the model. Even the noise column might be useful. Yes. The last modified, I mean, I don't know. This is a system field that Salesforce creates, similar to the created by field, where, this is system specific data. In this case, may or may not be consequential to the way that the data model is built. I'm assuming it's not. We're going to build this model, and then we'll see if we like the numbers, and then we may come back in here and say, you know what, I excluded it the first time, but let me try it with this column included and see, the results. So that's how data scientists kind of iterate through this stuff. So that's kind of how you want to think about how you're using it. Yeah, we definitely want these codes, the descriptions. The owner, that's me. Again, I imported all this data. I'm essentially the owner. It's going to be the same owner on every row in the table. I don't think that's going to be significant. But all the rest of the stuff looks good. So I've excluded some of the columns in our spreadsheet from the prediction model, but you can see that we're including most of them. Any questions about that so far? And later, what we're going to see is it's actually going to give us a report about how significant each of these factors was to the model. So keep that in mind. All right, so we save that aspect of our configuration.
Hi, I have a question
Okay.
about the overlay side of the data attributes. They have different types of data when we save the data and to activate. I don't know what the difference, like if we choose different type of the data, like what will happen?
Yeah, that's a good question. You're right. And that is an important factor to the models. Like some of this data is numeric, some of it is string. How does that impact the model? And that's actually, there's a lot of science to that. I won't be able to fully answer your question, but at one point I'll say, when I created this Excel spreadsheet that we looked at of my data, at one point you'll see that, actually it's over here. At one point I brought in the year data as just a like this, and so I brought it in as just a number, and it treated it as 2020. And then I realized later that was affecting the quality of the prediction. So I brought in that same information. I created an actual date for that. And then I think the artificial intelligence model started to get a better sense of, okay, well, we have time series data here. And when I did that and built my prediction based off of this versus that, the model improved, the prediction improved significantly. So to your point, that's an important part of the consideration that you have to make in terms of getting a quality prediction is do I bring this year data in as just a plain numeric, or do I massage it a little bit so that we actually get a time series data out of it? So questions like that are good because it gets you into the kind of mind that data scientists are going to have in terms of improving their predictions. Did that answer your question?
Yes, thank you.
Okay, good. All right, so now records to predict. So basically, as we saw up here, it's already, the data checker smart enough to know that we only selected a portion of our data and we left the 2020 data out. So it's already basically said, yeah, I think we know is we're going to use all the data that weren't a part of your training set, your example records. And that's the most common choice here. But I could, if I wanted to, I could say, well, I mean, maybe what I want to predict is not all of the 2020 data, but maybe we're going to look at the 2020 data just for Alabama, for instance. So I could do that, and then I could keep going. I could keep specifying criteria for what my scoring set is going to need to be. So I might say, yeah, I just want to look at Alabama data, and that the description is equal to health, or it contains the word health as the industry. Or maybe I'm interested in just electronics or something. So where the description of the industry includes the word electronics or health or that kind of thing, and then we're for that state. So the idea is we're going to train the data with our example set, but then what we want to see is we want to look at predictions specific to the state of Alabama and electronics in terms of what we want to predict. So you have those choices that you can make. And one important thing to call out here is that you can use and conditions like this, so that both of these conditions have to be true, or I could say, any of these conditions. So it could be that I want we're going to score data that is from Alabama, or the description includes the word electronics. So that would be Alabama data plus a lot of other data from other states where the description, the industry includes electronics, right? So you have a lot of options there, but you can also do some pretty fancy stuff here. And this is true on the filters that we created all the way through here, is that I can say, well, I want to do some, so I have 1, 2, and 3 as my criteria. And let me put in, let's say employment numbers are greater than 5,000. And then up here, I can say, well, the logic that I want is that it's 1 or 2 are true and 3, right? So you can create what is like a Boolean condition that defines the combination of factors that will determine what data is filtered in versus what data is filtered out. Okay, and so we had these capabilities all along, even when we were back here defining our example records, where we said that we wanted data to be earlier than 2020. I could have kept going. We could have created more criteria, and we could have had an or condition between those, or a custom logic condition, that kind of thing. So I just want to point out that that ability to create filters on the data is endless in terms of the types of conditions that you can create, and the custom logic that you have in terms of really pinpointing what portions of your data you want to include in your prediction. Any questions about that? Okay. All right. Okay. So we didn't make any changes there. So we're going to continue, and we did this part. So we'll next through there. And this is where we were going to refine what we wanted to predict. But in actuality, I want to leave it as is. So, well, I'm going to go ahead and say that what we want to predict is where the report date is later than or equal to, and we're going to select 2020 and go to the beginning of the year and select the first day of the year. So there you go. So what we want to do is create predictions based on all data prior to 2020, and we're going to predict the 2020 data. This will allow us to compare our prediction against actual data. So we're going to save and next, and that will take us to basically our review page, which is going to summarize everything we just did. Oh, no. So I have to give it a name of what we're going to, so the name is going to be, this will be the predicted 2020 annual payroll field. So that's where it's going to put the predicted value. which is good because then we'll, as we said, that we're trying to predict annual payroll. We're going to use annual payroll data, and then we're going to predict annual payroll data specifically for the year 2020. So this is where it's going to put the prediction as a field on our object. Okay, and so so we'll go ahead and do that, and then I go save and next, and finally we get our summary page. And this is where it's telling us, okay, this is everything you configured, you're all set up. If I need to go in, make changes, I can click on these things or click over here and do all that. Data checker looks good, everything is good there. And basically I am ready to build. And what happens then is when we build, essentially all this configuration information that we just created goes back into the machine learning system, and it pulls all our data in there, and then it starts building the models. And that can take up to, well, I mean, if we had millions of rows of data, that could take a few hours. You know, billions of rows of data, it might take a few days. But for the, you know, the 1,400 rows of data or so that I have, it's probably going to take about 10 minutes. But we don't have 10 minutes to sit here waiting. So I thought of that. And so basically, I already created this prediction and did a build. And that's what this is right here. You'll see that I have this predict 2020 annual payroll. The one we created is down here with the number 2 on it. It's in draft status because I didn't actually click that build button, right? So I already created this prediction. The machine learning system has already basically run, and it's created scores for us. So very quickly, let's go look at that, and you'll see it's basically essentially the same configuration that we had earlier, where we're, you know, we're using report data earlier than 2019. Actually, that's wrong right there. I apparently I said it. So we're only getting 2017 and 2018 data. That's it. That may explain why my predictions aren't that great. So I actually failed to include a whole year of data that I wanted to train my models on. So that, you know, may reduce the quality of the predictions. That was my mistake. When we were walking through it, I got it right. Like it up to and including 2019. In this case, I'm not actually including 2019 data. But all right, you know, no big deal. We can always edit this, right? I could edit this and essentially retrain the model and then get a new set of predictions back. But what I wanted to basically show you here is that I've already set this up. We let the machine learning system do its work, and then essentially it's in enabled status as a result. So let's go look at how that prediction looks like. So I was hiding this column earlier, but this is essentially the prediction field that we created. And you can see here we have 2020, the year is 2020 data, and here's annual payroll for Alaska agricultural industry. This is actual data, and here's our predicted data. Well, that's pretty far off, isn't it? So we keep going through here looking at this, and we're saying, okay, yeah, like, you know, we're seeing some big discrepancies here. So what's going on? Why did that happen? So one thing that we can do is we can always go in and view our scorecard, and we can see, okay, so one thing we know happened was I didn't give it the complete set of training data, so that would affect things too. But essentially, it's telling us what our top predictors were. So it's telling us here, it's telling us our model quality, by the way, estimated is kind of in the middle, good. And it's telling us that, well, 49% of our predictions are too high, and we definitely saw that. And 35% of our predictions are probably too low, but about 16% are pretty good. And then, you know, depending on our risk, our tolerance for risk, we could, you know, say, well, you know, if we're okay with like well, let's go big here, 50% risk tolerance, then much more of our predictions are rated as good than bad. But obviously, most people don't want to take on too much risk. So maybe we'll go with something like that. We get a different distribution on which of our predictions are scored as being quality versus non-quality. But but what were the factors? And this kind of points to the question that we had earlier in terms of, of the fields that I included and excluded, which ones were a big determinant on the model? And we're using linear regression here. So apparently what it's telling us is that the number of establishments in that state for that industry weighed heavily on the model, which kind of makes sense. I mean, if you are predicting payroll, you could kind of see that there's a linear relationship between the total amount of payroll in that state to the total number of businesses in that state, right? So yeah, okay, that kind of matches my intuitions. But then it's also telling us that another big part of the prediction was that description of the industry, where it included healthcare and social assistance, and also manufacturing and finance and insurance. But apparently it weighed heavily on records where healthcare and social assistance was the industry that we had data for. And I'm guessing because in terms of annual payroll, I mean, healthcare is a big, that's a big money industry. So there were probably a lot of large numbers for that category of data, or maybe it could go the other way. It could have been that there were a lot of small numbers. And so that sort of tipped the distribution in the way the prediction was being created. So if you end up with a lot of small numbers or a lot of large numbers, that kind of tips the algorithms. Or maybe it had a big determinant on the model because there was both a combination. There were some really large ones and some really small ones, and so it being able to balance the difference in the data that way, really stressed the model. So we don't really know. I mean, I'm not a data scientist. I'm an engineer, so but this is kind of how you want to think about what this information is telling us, and then it's telling us, a certain value. Okay, so state information was a big determinant of all this, and so this scorecard is kind of telling us, how each part of our data contributed to the model, and then we can drill down on some other things here. But we're kind of running out of time, so I'm gonna, unless there's a specific question, I'm going to skip out of here and talk about the other type of data, the other type of prediction you can create. Any questions so far?
And JP, I think we are almost at time. If there are more questions, I would highly recommend students to reach out to us directly. And JP, if possible, can you do a follow-up session with the team? I know this is a complicated product.
Mm-hmm.
There is a huge learning curve.
And so I do just want to jump in there really quick, and because there's two types of predictions I mentioned earlier, there's two types of predictions we can create. One was the numeric or linear that we just did, right? And the other one is what category does this data in? And so this is where we're using what's known as binary classification, or what's here listed as yes or no. And so what we did here is we same set of data, right? The same county business pattern data. But this time, and we're going to use all the data just like we did before, but this time I'm going to train my data. What I was all the yes data. What I did was I created a set of filters here of all the red states. Okay, these are all red states over here. And then the no category was all the blue states. All right. So, and what I left out of the data was swing states or purple states. So the idea is, what we want to do is create a prediction that will tell us, do those swing states fall into the yes category or the no category, right? And so that's, and then I kind of, you can see here is I excluded some of the same fields, but again, you have a lot of choice here in terms of what you want to include in the model, what you don't. And then here is where, in terms of what we want to score, is these are just swing states. So this is the set of data that we want to determine, is it a red state or is it a blue state? And then the way I defined my scoring field, because the yes values were red states, it's arbitrary. So what I'm saying is essentially the prediction I'm defining is it a red state is what it is, okay? Because that was my yes category of data. I could have switched it, not trying to be political here. Those labels are arbitrary. But because I put all the red states in the yes category, essentially the question that my prediction wants to ask is it a red state or not? And then so essentially, it's the same basic pattern. It's summarizing what we did. And then when we build that prediction, we would get a new column over here called is it red? And then it would give us a value indicating whether it scored it for those swing states. Did it score it as red or blue, yes or no? And so then that way we could, it's just kind of a fun example, but that I just kind of want to emphasize that as we're wrapping up here is that you have two types of predictions that you can create. One that's kind of based on how am I going to categorize things, and you're predicting, categorization, or time series data in terms of predicting future data, that kind of thing. So any questions